What's up, Algebra 2? Here we are with day 3 of our systems of inequalities. We're putting everything together with these story problems, okay? First one, this should be pretty similar to a story problem we did previously on day 2. 7 friends are going to the Linmar volleyball tournament. After paying to get in, they have $18 left for snacks. Popcorn is $2, candy is $3. We're going to go ahead and label popcorn as our X and candy as our Y. They need to get at least 7 items. Duh, they're 7 friends. They want at least 7 items. Write a system of inequalities. Graph it and state the points of intersection. Alright, so we got our common sense real world. X is greater than or equal to 0. Y is greater than or equal to 0. Can't have negative bags of popcorn and negative bags of candy. Okay? For me, given this type of a graph or a grid, I'm going to zoom all the way out and call this as going to be our Y equals 0 line. And this is our X equals 0 line. Okay? So now this is our new quadrant 1. If you want to go with that little quadrant 1 there, you can. I'm going to zoom out and have this be our quadrant 1. And that's 10, 0, 0, and this is 10. Alright, equation number 3, or inequality number 3, money. 2x plus 3y needs to be less than or equal to $18. And our total items, x plus y, greater than or equal to 7. Okay, so our purple one right here, you might not even need to do it, but you can just subtract that y over, subtract the x over, negative x plus 7. So we're starting at 7. 1, 2, 3, 4, 5, 6, 7. And we're going down 1 over 1. This is going to seem pretty boring, but doing all the slope dots is going to be helpful because these two lines are going to be very close together. Okay, this is a solid line. And we're looking at greater than or equal to, we're looking at above. Back to our green line, we're going to have to bring this down here to do a little bit of work with it. You might be able to do that work in your head, just write it down over here. Subtract the 2x. And divide by 3. Negative 2/3 x plus 6. See, they're going to be very close to each other because that one started at 7. So this one's going to start at 6. And we're going to go down 1, 2, out 1, 2, 3. There's where we cross. Down 1, 2, out 1, 2, 3. 1, 2, 1, 2, 3. Another solid line. Alright, and this one is less than under. So over the purple one and under the green one is just going to be this itty bitty little wedge. This little slice right there. Okay? Our corners are 7, 0, 9, 0, and 3, 1, 2, 3, 4. Okay, and I think there was another nice point in there, or 2 nice points in there that you could have used too. So it's not just I know that's a really small wedge or a little piece. It's not just those are our only 3 options. Parking lot problem. New parking lot addition is 80 square meters. Bus spots take up 8, so we're going to call bus X. Car spaces take up 5, Y. So x's are greater than or equal to 0, y's are greater than or equal to 0. the lot needs to fit more than 13 vehicles. More than, that's different. More than, so not greater than or equal to, just straight up more than, greater than 13. So that's going to be a dotted line, and we'll talk about that in a minute. Space 8x plus 5y, and we have 80 square meters less than or equal to 80. Can't go over 80 meters, that's all we have. Alright, I'm going to do the same thing again and just zoom out. I'm not going to just use that little itty bitty square. I'm going to use the whole thing. If you'd like to just use that itty bitty square, you can. You might have to change your scale. See, by doing this, I get an extra 10. So now I've got 20 up and down and 20 side to side. Nothing wrong with going with that little itty bitty corner there. And then you might have to go by like 2's sometimes. Green equation or inequality. Subtract the 8 over. Negative 8x plus 80. Divide by 5. Plus 16. So we really did need those extra spaces. Again, you could have gone by 2's if you just stayed in that quadrant, the original quadrant 1. So 16. So that should be 10, 11, 12, 13, 14, 15, 16. And we're going down 8, out 1, 2, 3, 4, 5. Down 8, out 5. Solid line, shading below. Just real light under there, just to remind yourself where it's at. Okay, the purple one, we're going to subtract the x over. This one's starting at 13, 10, 11, 12, 13. And just boring down 1 over 1, but we got to keep going until we see where it hits. And these do get really close for a while. So it's nice to do all the slope dots, because those, like, boom, boom, boom. If you just drew a line, it could look like it's going to cross there, there, there. And then down here we start getting some more separation again. But for a while there, if you would have just did like 2 points and drawn your line, it would have been really tough to tell the difference. And this one is dotted, greater than. This one's dotted or dashed. So then I like to just maybe go like every other dot. Okay, and we are greater than. We need to be above. Alright, so where are we? Above the purple but below the green. This little slice right here. So we have 0, 13, 0, 16, and 5, 8. Now let's talk about that dotted line. Remember the difference between dotted lines and solid lines. Solid lines have that or equal to part. So the points on the line count, because the points on the line are the equal to part. If you are just greater than, then the points on the line don't count, because the points on the line are equal to. They're not greater than. So because the points on the dotted line don't count, they're not greater than, this corner won't count, and this corner won't count. So of our 3 corners that we've identified, this one won't count, and this one won't count. This is the only vertice, only corner that counts in our solution region. Now there were a couple other nice integer values that got covered up there in that shading. You're probably not going to make a parking lot that does 0 buses and 16 cars. Maybe you will. Maybe this new parking lot over here, just for cars. Buses, you're over there. This spot over here, just for cars. Maybe. But you're probably going to have some sort of a combination. Right? You're probably going to have like 2 and 10 or whatever's going to fit in there. Okay? So that's just important there about the dotted lines versus solid lines. If it's on a dotted line, it won't count in your final answer. All right, and then our last type of problem we're doing, I think these are the best. These are the most fun because you're actually analyzing and seeing how this gets used. Okay, profit statements, maximizing profits. Sometimes you're minimizing costs. Okay, Francine's Flowers and Flora sells ferns and forget-me-nots. They profit $5 per fern that they sell and $7 per forget-me-not. Write a profit equation. So P for profit equals, let's call it, I just go in order, XY. $5 for every fern they sell, $7 for every forget-me-not. There's our profit statement. A model of all constraints is given below. Some things that they've been considered: cost to grow each plant, the amount of space it takes to grow these plants, the time it takes to grow these plants to get them to where they're mature enough to sell. Okay, things like that. Determine the number of ferns and forget-me-nots they should plant to maximize profits. Okay? The thing about maximum profits or minimum costs and stuff like that will always happen at a corner. Will always happen at a corner. Okay? So we need to write down these corners. Corner number 1, intersection point. We got 100, 200. Then we have 200, 100. Now the third point's a little bit out there. Okay, hopefully you can see that we're going by 20s. So we're at 200, 220, 240. And then this is one below 200 line. So we're going to be at 240, 180. Okay? Now don't forget our profit equation from up above. Now we're going to put those corners into our profit equation and see which one gives us the most. So we got 5 times 100 plus 7 times 200. That's going to be $500, $1,400. That point is going to make us $1,900. Okay? Let's have you take a minute to try the other two and see if you can figure out which point is the best. Which point's going to make us the most money? So go ahead and push pause and give that a try. Alright, let's see how you did. Did you get 1,900, 1,700, and winner, 240, 180 is going to make us $2,460. So we want to go with 240 ferns and 180 forget-me-nots. Alright? Okay, take a look at that worksheet for tonight. That worksheet also serves as your standard 1B quiz review, because the quiz is going to be just like that. Okay, you're going to have one problem like that on the quiz, and one problem like that on the quiz. Alright, thanks for watching. Good luck. Let me know if you have any questions.